So I've got that it's 2 o'clock. There's probably people still coming back from lunch, but I want to get started to make sure we get through all the content. And if we have some time for questions and answers at the end, we'll be able to do that as well. My name is Harry Pearson, and this is a session on making your Windows Store app more reliable. I'm an expert in making things more reliable. As you can see, I have this contraption on my leg that makes my leg more reliable. So that's why I'm here to talk to you. My Twitter handle is DevHawk. If you want to ask any questions, my email address is hpearson@Microsoft. So if you've got any follow-ups afterward, I'll be here for a little bit after the talk, and then I'll be over in the big room pretty much for the rest of the day before the party tonight. I want to start today with probably the most obvious statement that anybody's going to make at the conference all week. Good ratings and good reviews are critical to the success of your Windows Store application. This is probably obvious, right? Reviews and ratings are usually the only source of independent information that a potential customer has about your application at the point of installation. Maybe they read about it in a website, maybe they heard about it from a friend, but if you have a low rating, even those types of recommendations are probably not going to overcome a bad rating. If your friend tells you to go install this app that he thinks is cool and you go there and it's got a 1 rating and a bunch of really awful reviews, are you really going to install it? Probably not. From the numbers that we've seen, applications with low ratings are installed like an order of magnitude less often than applications with high ratings. You know, things in the 4 to 5 range, significantly more often than things in the 1 to 2 range. And chances are, if you're building a Windows Store app, your measure of success is how often your app is installed and how often your app is run. So it behooves you a lot to make sure you have good ratings and good reviews. So how do you get good ratings and good reviews? I don't know. I'm a type system plumber. I'm not an app developer. But I can tell you how you get bad reviews. Build an application that's unreliable. This is a survey that was published by a company named Apogee last year. It was a mobile app user survey. They asked a bunch of different mobile app users about their rating and review methodology. And what they found overwhelmingly was that the number one reason why apps got bad reviews was because they were unreliable. Apps that froze or apps that crashed. This was more important than apps that were slow, apps that sucked down your battery life, and apps that were plastered head to toe with advertisements. If you want to make sure that your application does well in the store, you need good reviews. If you want good reviews, you need to avoid these kind of bad reviews that are stemming from unreliability. So how do you avoid having an app that crashes or freezes? Well, we're all engineers here, right? And there's obviously been a ton of procedure and process and methodology for building applications that are reliable. Test-driven development, behavior-driven development, you unit test, you beta test, you user acceptance test, you integration test, you test. Right? At Microsoft, we try to have an order of like 1 tester per PM, per developer. Right? That's how critical testing is. But I will guarantee you that no matter how much testing you do, you will find bugs after you ship. Bad things do happen to good apps. The reality is, you can do all the testing you want, but your customers, they live in parts of the world you don't live, they speak languages you don't speak, they have hardware that you don't own, and they're connected to networks that you don't have access to. They will find problems in your application. For any reasonably complicated application, I absolutely guarantee it. And there's no way, when you consider the test matrix, there's no way you can cover it all. Now, this doesn't mean you shouldn't do any testing, okay? I'm not suggesting that. But don't think that all of the testing that you do is enough. It's important, but it's not sufficient. You need to stop thinking about your application's reliability as a binary state. My application is unreliable, my application is reliable. You need to think of it more of a process. We want to make our applications more reliable over time. We ship our first version. We find out these assumptions that we made based on hardware, based on language, based on location, based on network topology, and we feed that back into our application development efforts in order to improve it. We're seeing in the store that applications that are updated more often have better reviews. They're engaged with their community, they're listening, They're adding the features their customers want, and for the purposes of this conversation, the most important thing, they're fixing the bugs their customers are finding. They're fixing the bugs that can only be found on customer machines. There's one takeaway from this conversation, from this presentation, it's this. You need to monitor and regularly improve the quality of your application in order to avoid that #1 reason why people give your app a bad review, unreliability. This is a constant process. When you first publish your app to the store, that is the start, not the end of the process. We're going to talk about this in a series of steps. We're going to start by talking about the information that we collect on your behalf automatically and that is available to you in the Windows Dev Center. We're going to talk about how you can supplement that with building your own logging. As part of that, we're going to talk about some new APIs that we're introducing in Windows 8.1, and then we're going to bring it all together in a demo at the end. Is that cool? And hopefully we'll have a little bit of time for questions at the end. So, let's start by talking about the Dev Center. Part of the idea is that you need to monitor and improve. So let's talk about how one goes about the monitoring. We automatically collect a set of telemetry and analytics about your application that we make available for you automatically on the store. There is no additional cost, there is no additional effort. This is already there for you automatically. Now, analytics and telemetry sound like they may be the same thing. They're subtly different. Analytics are things related to the store. How often has your app been installed? What is the ratings? What are the reviews of your app? Telemetry has to do with your app at runtime on customer machines. How often is it run? How long does a typical user session last? Does it crash? And where? We provide this information for you automatically on the Dev Center. Right? So if you've ever been to the Dev Center, and if you've published a Windows Store app, you've been to the Dev Center, up there in the upper left-hand corner is the button for the dashboard. If you click on that, it'll bring you to this page. This is where you go to submit your app. I'm sure, as I said, if you build a Windows Store app, you've seen this. In this example, I have this app that we're going to look at later, Cloud Connoisseur. I hear cloud computing is a big thing. There was a whole keynote about it this morning. And so here I've got this app that's in the store, and I want to be able to drill down and get more information about what's going on with my app now that I've actually published it. I've actually got 2 versions of it out there in the wild. So there's a button here called Reports. I can drill down and get more information. Now, of course, your eye is immediately drawn to the charts at the top. How often is my app getting downloaded? How many ratings, how many reviews am I getting? This is the kind of analytics that I was talking about before. There's also the question about how much money I'm making. To be very clear, this is entirely fake data. If I could make $800,000 building a simple cloud demo app, the way I'm going to show you in a minute, we'd all be having this conversation on my yacht rather than here at the convention center. The part of this that I want to talk about, however, is this box. This is the high-level reporting about the quality information about your app. How often is it crashing? And if you click on this button, the details, again, you can drill down and get more information. We provide you these charts, and we provide you more detailed error reports about 3 different types of errors. JavaScript exceptions, and if we scroll down here, your crash rate and your app unresponsive rate. Now, JavaScript and crashes are kind of the same thing. They are cases where your application has some type of unhandled error or exception, and Windows has decided to terminate your application proactively. We have a philosophy around this that if you have an application that has got unhandled errors, we expect that that is the kind of thing that occurs when you have an application that is in some kind of corrupt state. And rather than letting it continue to execute in a corrupt state, we terminate it proactively. We separate them out because JavaScript errors and native or managed errors, you get very different kinds of information back from the system. What you get back from a JavaScript exception is essentially a text dump of the error object, and it's a text file. And it'll show you all of the same things that you can inspect in your JavaScript application on the error object if you were to catch it in a try-catch block. For crashes and for unresponsive apps, we actually give you a crash dump of the process's memory dump. We give you a memory dump of the process. We separate out unresponsive apps from crashed apps. Now, if you're familiar with desktop computing, you're probably seen an application that's decided to do some long-running operation on the UI thread. Windows will automatically gray it out. That doesn't happen as much in Windows Store applications because the underlying infrastructure of the Windows runtime is asynchronous by default. it's actually you have to go out of your way typically to do those kind of long-running operations that block the UI thread. Now, you could do some kind of long compute operation, of course, but any kind of network access or I/O or file access, those types of things are asynchronous, so you don't usually block your UI thread that way. But the place where responsive apps becomes into play in Windows Store apps, at least in my experience, is when it comes to suspension. If you're familiar with the API model, the execution model for Windows Store apps, when you're running in the foreground, you have full access to, you've got no Chrome, you've got full access to the UI, you're running at full speed. The user decides they're going to run some other app. They bring up the start menu, they switch to some other app. Your app goes to the background. And you've got a small window to write sort of what you were doing to disk before you're suspended. That window, I believe, is around 5 seconds. Now, the idea here is that we're going to freeze your app. It's still going to be resident in memory, but we're going to halt all of your threads where they are. If the user brings you back to the foreground, then all we have to do is restart those threads and you're right where you left off. But it's possible that the system will choose that it needs to free up resources. The users run a whole bunch of apps, you're running out of memory, you've got a small footprint device, we need to start terminating apps in order to free up memory. So it's possible that you will go from the suspended state to the terminated state. And of course, because you're suspended, you're not executing, at that point you don't have any ability to save what you were doing. So you have to do that work during that 5-second window when you're suspended. If you exceed that 5-second window, you get terminated. That's what a lot of these unresponsive app reports are. There are cases where your app has not finished its suspension within that specified window. Now, as you can see in this fake data, I'm going the wrong way with my reliability. My second version of my app is crashing more often than my first version. Whatever new cool feature I added in the second version is causing problems. So when we get to the end, we're going to actually go through and see how we can add some additional information so I can figure out what I've done wrong. Now, as I said, in addition to these sort of high-level reports, which give us the ability to see how our app is doing at a high level, we can also get these crash reports. These crash reports are intended to give you a mechanism by which you can troubleshoot your app to find out what's wrong. But in reality, they're not really as useful as you might think they are. There's three main reasons why they're not that useful. The first is privacy laws. This is kind of a big deal right now in the United States in the news. You might have noticed something about it. Every country, every municipality, every city, state, what have you, has laws that govern the collection and transmission and distribution of personal information. Users using your app have some personal information almost assuredly running in the process. So when we take a snapshot of that, we have to be very, very careful about how we collect it and how we transmit it and how we distribute it, which is to say how we give it back to you. If there's some string in memory, we have no idea if that's the name of some band that's playing at some after-hours party at the Build conference, or if it's the user's social security number. We have to be extremely conservative about this. So we essentially overwrite any of these local data fields with garbage data. So if you have a function that's crashing your app because you're getting some kind of, like, oh, my app always crashes when the parameter is this, you have no way to determine what this is from the crash dump, because we have no way of knowing whether that is private information or not. So we have to overwrite it. Of course, and we'll see in the next section, you guys know better about what's happening in your app, so you can supplement this logging with this telemetry with your own logging. The second problem with this is that it's a snapshot in time. It is the point in which the application was terminated. And often that's not the point where the error is actually occurring. You have some error, and then the app continues to execute, and then you terminate it. This is the snapshot, but the error was over here. So the ability to sort of work backwards and figure out what caused you to get to this state where you terminated is much more difficult. The longer that window is, the less valuable this error report is. And finally, not everything that goes wrong in your app results in an error terminating event. Right? If you've got some kind of productivity app, I'm going to build an app that takes notes. And so I'm taking notes, and then something happens, there's some bug in the app, and the data gets corrupted. And now all my data is gone. The app never crashed. It's never going to show up on the dev portal. It's not going to show up on those nifty graphs. You're never going to get a crash dump. But your user is still going to give you a bad review because you accidentally lost all of their data. So because of privacy, because of the snapshot issue, and because of the fact that there are errors in your system that may not result in termination, you need to look at how you are going to supplement the standard telemetry that we provide you with your own additional information. And that's what most of this talk, as I'm on the wrong computer, sorry about that. That's what most of the rest of this talk is going to be about. We have built-in infrastructure, some of it that's there in Windows 8, and more of it that's coming along the line with Windows 8.1, that helps you really add this additional telemetry to your system to be able to collect more information, information that's relevant to you, information that's temporal in its context, and to be able to figure out how to do a better job of debugging your application when it's crashed in the field. So the main idea of these temporal logs is that they're occurring over time, right? So usually when there's a crash in your system, you want to be able to go back in time and see what's happened. So what you really want to be able to do is to have some history of what's going on in your application. This happened, then this happened, then this happened, and then I crashed. I want to know what those things are. And if you're doing your own logging, in addition to the telemetry we're providing you, right? I'm not to say that we're going to get rid of that. It's just in addition to that, you want to supplement. You can really improve your chances of figuring out what's going on in these customer machines. The first thing we're going to look at is that we have a whole new API in Windows 8.1 for doing logging. Now, if you're at all familiar with Windows sort of at a deep level, Windows has a fantastic infrastructure for doing logging. It's known as ETW, or Event Tracing for Windows. It is incredibly powerful, it is incredibly fast, and it is incredibly flexible. And like anything that is incredibly powerful and incredibly flexible, it is not particularly easy to use. So we have introduced in Windows 8.1 a new API. It uses ETW under the hood. It's a fantastic infrastructure. But we have a new API that's designed around having a great developer experience too. There's two primary ways in which you can use this API. One for the scenario where I want to know the things that led up to a crash, and one for the scenario where I really just want to know everything that's going on in my app. Right? There's a lot of interesting philosophies about how one goes about running a business with a Windows Store application. Right? I want to get a minimally viable product out there, and then I want to evolve that product based on how it's used. I can do logging with this API for both of those scenarios, both for crash analysis, as well as for those sort of long-running, lean startup types of approaches. So the log to memory. This is I want to keep a recent log of all the stuff that's gone wrong in my app. When I detect an error, I want to send that log home. Right? That's the scenario. So we have these two new types, a logging channel and a logging session. They're extremely easy to use. We'll see the code for it in a minute. But I can have multiple logging sessions, and they're associated with multiple logging channels, and they're all associated with a logging session. And those logs are sending messages to the logging session. Now, the logging session is implemented essentially as an in-memory buffer. It's a circular buffer. So as these messages continue to come in, we're going to start once we fill that buffer up, we're going to start overwriting the oldest records in the buffer. Right? Again, this is not intended to be a permanent record of everything that ever happened in this run of your application. It's only the most recent n number of events for some value of n. Now you detect a crash. Right? Either we've got some new code in a new infrastructure that allows you to observe terminal events before they actually terminate your process. We'll talk about that in a minute. Whatever, or maybe you have a scenario like we talked about with the corruption, where you detect you're in a corrupt state and you want to figure out how you got to this place. So what do? You say, okay, I want to save that to disk, and then I can take that file and I can do whatever I want with it. In particular, I'm probably going to upload it to some back end where I'm going to do processing, and I'll be getting all these error reports from all these different machines, all these different devices, get them all to my same back end where I can do analysis on it. As I mentioned, this is an incredibly simple API. So here's what it looks like. I'm going to create a new logging channel. I'm just going to new up a logging channel. All these types, by the way, are in the windows.foundation.diagnostics namespace. I've eliminated that from the slide just because it was too long. You wouldn't be able to see it. So I new up a new channel, just var channel equals new logging channel. Now another thing is, channels may or may not be active. Right? If I just new up a channel and I never associate it with a session, it's not active. I can log messages with it, but they immediately get discarded. Now, there's overhead to making that call, So we provide a mechanism so that way applications can listen to see when the state of the channel changes. Is the channel enabled, and what's the channel logging level? Of course, there's an enumeration: verbose, information, warning, error, and critical. Right? I want to collect, this level and above. When I go to make a log message, when I go to log a message, again, it's very simple. It's a single line of code, but here I've wrapped that in an if statement because I want to say, oh, well, I'm going to log this level. It's an error. I want to make sure that the channel is actually listening, is actually going to do something with this message. So if it's enabled, and if the logging level exceeds the logging level of the message, I'm going to call. And there's basically two methods you can call on the channel. One logs a string. The other logs a string and an integer. Right? So you can imagine this is very simple, string-based logging. Now the other, then now there's so that's essentially the source side. Now we need the listener side. And it's almost as easy. I create a new logging session the same way I create a logging channel. I just new it up. And then I associate the channel with the session by calling add logging channel. When I want to save that information, there's a function I can call called save to file async. I give it the folder. This is a storage folder, so it's one of the windows.storage.storage folder objects. And I give it a name. That's just a string. And it will give me back, it's an asynchronous operation. It's I/O. Everything in Windows runtime that involves I/O is asynchronous. It gives me back a storage file, which I can then turn around and upload to the back end if that's what I want to do. We're going to talk about uploading when we get to the code part of the demo at the end. So that's in-memory logging, circular buffer. That's great for I want to know the last set of things that occurred in my app before I crashed. But for I want to know everything that went on in this user session, I don't want to use the logging session. I want to use the file logging session. It turns out it works almost identically. As I said, this was an API that was designed around developer experience. It doesn't have the power or the flexibility as ETW, but it's designed to have a really simple-to-use API. Here I want to log all the events to disk. Everything that happens over the course of the lifetime of this application, I want a permanent record of. Now, I don't want to have one big, huge file that gets into the megabytes and gigabytes. So at some point, we're going to reach some max file size, and the system's going to tell me, and I'm going to take that file and I'm going to upload and process it. Now, I can still crash, in which case I may want to flush that information that's currently in the buffer to disk. So again, we're going to send messages to the channel. We use the same logging channel. That doesn't change. We're sending those now to a file logging session instead. Those are buffered in memory for performance. We batch write them to the disk, which is why you have to think about if you do have a crash, you need to flush what's in memory to disk before you terminate. But those do automatically get flushed to disk. As those continue to go, eventually we're going to fill up that log file, and you'll get an event that says, hey, we reached the file size limit for this file. And then you can say, OK, great, I'm going to go make a copy of that file, and the logging infrastructure will just start writing new sessions, new events to a new log file. And of course, you can take that log file, and you can do whatever you need to with it, particularly upload it to some back end for further analysis and processing. This API is almost as easy to use, slightly more, because it's got this additional event. I new one up the same way I new up a logging session. I just say new file logging session, and I associate it with the channel the same way. There's this new event, not new, but it's a whole new type, so it's not like it's new in Windows 8.1. The whole type is new. But there's this event, log file generated. When that event fires, then I want to take that file. The file comes in as an argument to the event. I can take that file, and I want to move it somewhere else before I process it. The folder where this stuff, where these logs are generated, the logging infrastructure will automatically clean it up. So if you want to make sure that that is persistent, that you own the lifetime of that file, you need to move it somewhere else. Right? So that's what I'm doing here. I'm moving it to some other folder. And again, if I have the same kind of crash scenario, I want to flush the stuff that was in memory to disk. So there's a function. It's very similar. It's got a slightly different name than log session, because it's not a save, it's more of a flush. So they call this close and save file to file async. But again, it works basically the same way. I call it, it saves it to disk, it's an asynchronous operation, and it gives me back a storage file. So that's how you want to add logging to your application. Very simple. You just use the logging channel and then either logging session or file logging session. Now that's great, but you also want to make sure, where do you actually decide? How do you know when you've reached some kind of error? There are going to be some scenarios that are going to be inherent in your application, like you know that, okay, well, I went to read the data and it's corrupt. But there are these terminal events. As I said earlier, Windows will proactively terminate your application if we see an unhandled exception or an unhandled error. We consider that a sign that your application is in some type of corrupt state, and we proactively shut it down before it does more damage. We now have in the platform a mechanism that allows you to observe and potentially handle these errors. We've also done a bunch of work that I'm going to talk about briefly now, but I don't really have code samples for because it's mostly infrastructure work. We've done a lot of work in order to make errors and exceptions in Windows work better. We've done work to make sure that if I throw an exception on one side of a language projection boundary and I catch it on the other side, that it's the same exception object. We've done work to make sure if I throw an exception in one language and catch it in another, I'm in C++ for my backend, I throw an exception, I catch it in C#. In Windows 8, the only information that we got across that language projection boundary was the H result. Now, not only do we get the H result, we also get the error string, which gives you a much better chance of figuring out what's going on wrong on the other side of the projection boundary. We've also done a bunch of work to do a better job propagating errors. As I mentioned, this is using error codes under the hood. We use error codes under the hood for a variety of reasons, right? Especially performance. There's a lot of overhead that goes along with using exceptions. Of course, exceptions are an incredibly powerful and useful way of managing your error code in your application, which is why literally every single language projection that we produce, JavaScript, CLR, and C++, all are exception-based. So developers, you guys, expect errors in the Windows platform to propagate the same way that exceptions do. And we've done a better job of that in Windows 8.1 than we did with Windows 8. Now, if you're a XAML developer, you might already be familiar with the fact that there's an error event in the XAML that hangs off of application called unhandled exception. And this maybe sounds a little bit like what I'm talking about, this idea of being able to be notified proactively about errors that are occurring in the platform. And the reality is that it is. I'm sorry. Yes. I'm sorry. I jumped ahead. My mistake. The exception handling mechanism that's in XAML was great if you had an error that occurred while you were in a XAML function. So, for example, if you threw an exception in a XAML button click event, it would end up in the XAML unhandled exception handler. If, on the other hand, you threw an exception in the network status changed event, it wouldn't end up in the XAML unhandled exception handler, because we didn't have the same infrastructure in the platform that the XAML guys had built in their framework. So that's one of the things that we've changed. We've added this new infrastructure at the core platform, and the XAML guys have done the work to integrate with it. So if you're a XAML developer and you're already using that exception handler mechanism, you can continue to use it. All the changes that you will now see more events that were otherwise terminal and were going unobserved. Now you'll get to see them. You'll be able to log them. You'll be able to do something about them. You can continue to use that if you wish. It's actually a better API to use if you're a managed developer. It turns out that C++ developers have a hard time using that API, because where managed developers have one common root exception type, system.exception, the same thing doesn't occur in C++. So they cannot project a single common exception type the way that CLR can. So in the version that we have in the core platform, we've built something that works for both CLR and C++. JavaScript actually uses its own completely separate mechanism of on-error. The other great thing about this infrastructure is that you can do it for logging components. Previously, you only got this if it worked as part of the XAML framework. So not only did you only observe errors that occurred in XAML framework, you also were limited to taking a dependency on the XAML framework. Now, this infrastructure is in the core platform. So you can build a logging component and use it with any kind of application. A HTML5 Windows application, a C# XAML application, a C++ XAML application, or a DirectX application. So in those kinds of scenarios, if you're a C++ developer or you're a logging component, you probably want to use this new core application unhandled error detected event. If you're already using the XAML one, XAML's unhandled exception, you're absolutely fine to continue to use it. All unhandled errors will be observed in both places. So let's take a look at what this code looks like. As I mentioned, this is going to seem a little strange for a .NET developer. This is absolutely the standard way that you do this in C++. So you get this event, and you get this unhandled error argument, and you call a function on it called propagate. That will rethrow your event. It will rethrow your exception, which you then immediately catch. As I said, as a .NET developer, that seems kind of odd. You just say, oh, well, I've got system.exception, I'll just inspect it. But again, C++ doesn't have a common consistent exception root class, so they don't have the ability to do that. In this case, I am using Java. My whole demo is in C#, so that's what this code is. Now I'm going to catch that exception, and I'm going to do something with it. In this case, I'm going to log it. I want to observe this exception, so that way I can send a message home that says, this app crashed on this machine, and this is what it told me. This is why it told me it crashed. Now you'll notice at the end here, I've added a throw. When you say throw in C#, C++ works the same way, and you don't provide it inside of a catch handler, it will just automatically rethrow that same exception. And that's a very, very important step. I am not trying to swallow every error that's occurring in my application. There's a good reason why we proactively terminate applications that are having unhandled exceptions. The application's in a bad state. You don't want it to continue executing. But you want to observe. You want to know why. And so that's the reason that this works this way. So I'm going to rethrow the exception by calling propagate. I'm going to catch that exception. I'm going to log information about the exception. And then I'm going to rethrow the exception so that it continues to propagate. The Windows sees the exception and terminates the process. Just for comparison, the XAML app object has an unhandled exception, and it looks this way. Because you're not propagating it, you don't have to rehandle it, you don't have to throw it. So this is a significantly simpler API to use if you're a managed XAML developer. As I said, if you're C++ or you're building some kind of component, this is probably not what you want to do. But this is absolutely fine. There's no reason or no problem with doing it this way at all. For my demo, as you might imagine, we're using the core application version because that's the new one. That's what I want to show off. That's what my team built. So that's why we're going to see that one. If I was on the XAML team, we'd look at this one. Question? So the question was, in a C++ application, would the application just close if you don't rethrow it? If you catch the exception in C++ or in CLR, it doesn't matter between you, the languages work the same way in this case. If you catch that exception, at that point, the app will not terminate. You have to rethrow it in order to get the termination experience. So you could just say, oh, I'm going to listen on this unhandled error detected event. I'm going to rethrow, I'm going to catch it, and then I'm just going to swallow it. And my app will never crash. It will just get corrupt, and it will throw away users' data, and it will be a bad experience, and you'll never find out what's going wrong in your application. Don't do that, right? You definitely want to rethrow. This is a channel for observing. Now, if there really is, like if you can catch something here and you can proactively do something about it, then go ahead and do it. Like any try-catch block. You don't ever want to just swallow blindly. But if you can actually take some proactive action to fix the problem, you should absolutely do it, right? Whether it's here or whether it's a try-catch block somewhere else in your code. But you don't ever want to do blind try-catch and just swallow exceptions. That's just bad programming practice in general. Yeah, for network exceptions, you might want to retry just to repeat the question about network. In fact, there's a great talk specifically about network things like retry. The new HTTP stack that's in Windows 8.1 has got some great functionality under the hood in the concept of filters. There's a talk, I believe, at 5 o'clock today and one tomorrow morning at 9 on that both talk about that stack. The one at 9 tomorrow is like a deep dive on that topic. So it's definitely one to look at. So we all seen enough slides? Let's look at some code. If I can log into my system here. Okay, so this is a very simple, we saw earlier, I've got this application called Cloud Connoisseur. I keep hearing about how important cloud computing is, and so I decided to build my own app with pictures of clouds. Okay, This is all hard-coded. This is a very simple sample app. It looks much better than the sample apps that I've built in the past because I'm using the great, cool, new hub control template out of Visual Studio 2011 and dropped in a bunch of pictures that were all CC licensed on the internet that I found. They're great pictures, but I have this slight problem that if I click on this one, my app will terminate. And it will go away. And that's the termination experience. The app goes away. So we saw that whatever feature I added in the latest version, I was getting this problem. Now, okay, so for the purposes of this demo, it's very simple, right? What I've done here is that in that event, I'm just throwing an exception, right? Clearly, it will be much harder to find exceptions in real non-sample, non-demo apps that you do on stage. But the point here isn't to have a big, complicated application that's hard to debug. The point here is to look through, understand how the new logging and how the unhandled exception handling works. So let's go over to app, and you'll see here that in app, I've already created these private local variables, one for the logging channel and one for the logging session. For the purposes of this demo, I'm using logging session. So this is the in-memory buffer. I'm going to save it to disk when I see a crash, and I will send it to my back end. I totally could use file logging session instead, but it just was simpler from a demo perspective to do this one rather than the file logging one, which takes time. You want to run your app for a while, that kind of stuff. I've also created a log session resource name, and I'm going to need that here in a minute. So I'm going to write the incredibly complicated code to set up my logging channel and logging session. We saw it on the slides earlier. Log channel equals new log channel, and I'm going to call this cloud connoisseur.app, and I'm going to create a new log channel. A new log session, and I'm going to call that cloud connoisseur logging session. Now, of course, you can have multiple sessions and multiple channels. We're actually going to see multiple channels in this application. I've only got the one session, but if I wanted to, you could imagine saying I want to have some kind of low-level, always-on kind of thing for usability, and I want to have more detailed information that I only send back in the case of a crash. You could even imagine saying I want my application to phone home and dynamically change what I'm actually logging. Oh, I'm seeing problems, so I want to change the default logging level from critical to error, or from error to warning, or what have you, right? I'm hard-coding it here, but there's no reason why you have to do that. The ability to dynamically update this stuff on the fly is an important thing to think about when you're designing your application. You don't want to get too much information, but you want to be able to turn up the knob when the time comes to collect more information to troubleshoot a problem. So now I have my session and my channel. I just need to associate them, so I'm going to say log session.add logging channel and pass in the log channel. Again, very simple. And I'm going to use the default logging level of information. As I said earlier, these are the various levels: critical, error, warning, information, and verbose. Of course, IntelliSense puts them in order alphabetically rather than in order numerically. So, but in this case, information is the second lowest. The most verbose is obviously verbose, and then information, warning, error, and critical. I'm not going to bother with the event management stuff. I'm just going to log everything automatically. The other thing I need to do is I need to make this session available across my application. I want to have a separate logging channel per type. I don't want to have to share the logging channel for everybody. So what I'm going to do here is I'm going to make it available by putting it in the resources collection. Now, you're probably familiar with the resources collection from a XAML perspective. It's used a lot of times in order to build things in XAML and make it available to other parts of XAML. But all it really is an in-memory dictionary that you can use to stash away whatever you want. And that's what I'm going to do here. So I'm going to say resources, and I'm going to use this log session resource name. I'm using this constant string, so that way I'm sure I don't have any typos when I go to access this in other parts of my app. And I'm just going to stash away the log session in there. Now, the last thing I'm going to do here is I'm actually going to call a function called, not on log session, log channel, a function called log member name. This is not a member of logging channel, right? We saw the entire API set on the slide before, and you can tell from the IntelliSense that this is an extension method. I'm using C# has this great functionality. We'll just go right here to take a look at this. I've built a couple of extension methods so that I can log a member name, and I'm using this great feature that was added in C# 5 called caller member name. So this looks like I'm just sort of inherently setting this string to an empty string. But what's actually happening is the C# compiler, VB does this as well, will automatically insert the calling function's name. So that way I don't have to type it out all the time. So this is a thing that's specific to C#. That's why it's not done at the Windows runtime level. It's something I've added myself. I've also got this other function called log data so that I can log 2 strings, and it'll automatically format them. It's just a little bit easier sometimes in some of the types of scenarios you want to do. You don't have to do that. That's just what I did in this case. So now I've got my log channel, and now I'm logging. So I'm going to start up. I'm going to create my channel. I'm going to create my session. I'm going to connect them together. I'm going to stash the session away, and I'm immediately going to log. Now, if we go over to the hub page, you'll see that I've actually already done the work here. Now, originally, when we ran the app the last time, I was logging, but all those things got immediately discarded because I hadn't associated the channel with the session. So you can see here in my constructor, I've got some code here that's going to go off, and it's going to look in the resources to see if it has the log session. And if it does, it's going to associate it with the log channel. I'm just newing up the log channel using a default assignment here. This is the way C# can do construction. So again, I'm just using the type name. It's a common way of doing it. It isn't the way you have to do it. It's just the way I chose to do it for the demo. Whatever way you want to do for naming your channels, you can do it however you'd like. And I've now gone through and I've added a log member name to every single one of my functions. By the way, something I didn't talk about on the slides, there's also a type called log activity. So I can actually say log activity is nice because it's great for starts and stops. So I can say using var activity equals new logging activity, and I can give it a name, some name, and I can give it a channel. And because this is using a using statement, now it'll automatically, if I can type, excuse me, it'll now automatically log something at the beginning and at the end of the function. So I can use the deterministic finalization of using, or in C++ you have you inherently have deterministic finalization. If you want to use this from JavaScript, you can, but you have to call close explicitly on the activity. So again, it's not a huge thing. It's just another small thing that makes the API just that much simpler to use. Now, if we come down here, we'll see my pointer pressed. If I click on that image, I'm throwing my incredibly useful something bad happened exception. As you can tell, I'm the guy who writes all the exception messages for Windows. No. We're getting better at that. So I'm not actually doing anything here. I'm not doing anything to do anything about this exception. I don't have this wrapped in a try catch. So if I run this under the debugger, this is the default. I'm running the universal version, but this works the same on the Express edition of Visual Studio. If I click on this, I'm going to get a first chance exception. Because this exception isn't handled in my code, Visual Studio is immediately going to stop and say, hey, you're running under the debugger. Something bad happened. Do you want to do something about it? Do you want to inspect it? So that way, this is great for live debugging. This doesn't work on a customer machine, but it's great for live debugging. And if I continue, it's going to give me something about wanting to attach a debugger, all the normal things that Visual Studio does when your app crashes under the debugger. So now that we've done that, let's see how we can actually inspect that exception before it terminates the app. So we can actually maybe find something out more useful. So we're going to come back here to the onLaunched event, and I'm going to call a function that I've conveniently already written called register unhandled error handler. So let's go down here and take a look at this. So there's 3 things to look at. The first is I have a private variable for the log folder. This is the place where I'm going to save the logs on error. I'm going to make sure I take care of this at the beginning because I want to do the least amount of work possible in the exception handler. So I'm going to pre-populate this type. When I register, I'm going to go off and I'm going to create a folder called log files to upload. So I'm going to create this folder. It's just an object. It's going to be associated with my app. And then if I ever crash, I'm in a position where I can save that stuff out to disk. And then I'm going to wire up the unhandled error detected event. Like any other error, like any other event, You would wire it up exactly the same way. And now here's the unhandled error code. Again, we have this try catch, a little bit odd for .NET developers, but it actually works pretty well, as you can see here. I'm going to log 2 pieces of information about this error. I'm going to log its H result, and I'm going to log its message. We all know that there's more information inside the managed exception. I might want to log the exception type. I might want to log the exception stack trace. There's all kinds of other stuff. That's all I'm doing here. Nothing that says you can't do more than that. And I'm going to give this a log level of critical, because this is obviously a very big deal. My app's about to terminate. I want to make sure that I'm logging this. So then I'm going to say, okay, I'm going to make sure my log session isn't null, and now I'm going to save it to disk. So here I'm going to just generate a file name. I'm using the current time. All of the data that I really care about is inside the file. So the name of the file is kind of irrelevant. So I picked this in order to make sure it was unique. I could have also generated a GUID or done any kind of other things. In this case, I just picked the time. And so now I'm doing something that we tell you never, ever, ever to do in production code. I'm going to log this session. I'm going to create a task, and then I'm going to block the UI thread. We talked about this a little while ago, that we don't normally see this in Windows runtime applications, Windows Store apps, because we are pretty consistent about not doing this. However, if I let this application asynchronously save to disk, by the time that completes, my app is probably going to be gone. I don't want the app to terminate before I get a chance to actually process the rest of my unhandled error handler. So I'm going to do something that we tell you to almost never do, and that's block the thread. If you were doing some kind of error detection inside your app that wasn't related to the unhandled error handler, if your app wasn't about to terminate, then I would totally be using the normal await keyword and writing this code the normal way. But because I'm about to terminate, and because I know I'm going to throw the exception again and then I'm going to crash, I want to make sure that this work completes before I continue on. That does mean that the user may see a pause. But better that there's a pause than we lose all of that rich logging data. So I need to be able to find out how to fix this later. So I'm going to call a method. Save file to async is a Windows Runtime API. It returns an iasync operation. .NET has an extension method that will wrap that in a task. This happens inherently when you await, but we're going to do this explicitly so that we can call task.wait. This function blocks the thread. You don't ever want to do it except in this one case. And then, as I said, we're going to rethrow. So now, when I run my code, and I do the incredibly dangerous thing of clicking on a picture, I still break here because I'm running under the debugger, but now we end up in the unhandled error detected function. We rethrow, we log, you know what this is all going to look like. And we throw, and again, we get again, because we're throwing an exception that's not handled, we get that same behavior out of Visual Studio, and then we get that same, you've got an unhandled error, do you want to handle it, do you want to attach a debugger, that kind of behavior that you always see with Visual Studio. Now, if we go and we look, this is the app data folder. I've built a shortcut for it so we can be able to get to it quickly. And we look in local state, log files to upload. There's the file that I just generated. So now I need to get it off my machine, because it's on the customer machine. I need to get off the customer machine and get it back to my cloud. So what I'm going to do is I've got I'm going to run up a second instance of Visual Studio where I built a very, very simple ASP.NET Web API app. This is incredibly simple. I'm just using the standard Web API, and this is the last version. I don't know what those guys are announcing at the conference, so I'm sure there's some really cool new stuff. I just didn't use it. This is really simple. I'm just taking in a request and sending a response. And I'm cheating here, right? I'm writing this to my user directory. This is great because I'm running this with the IIS Express under my user credentials. This would never work for a real production web server. But it's great for demonstrating to you guys. And all I'm going to do is I'm going to save it to disk. And here, again, remember the file name doesn't matter, so I'm just generating a GUID this time. So now I'm going to I'm going to run this app. So now I've got it's running in the, so the other question is, how do I actually get it uploaded? Almost forgot that, my mistake. So there's a variety of ways to get this code uploaded. It turns out there's a great piece of infrastructure in Windows called the background uploader. And that's what you want to use to do this upload. What's nice about it is it decouples the process of uploading from the activity in your app. The problem is that if your app is not running, your upload is suspended. So if your application is suspended, the upload will continue. But if you terminate, we stop uploading, which of course is exactly the scenario that we're talking about. So what I've done here is I've actually gone through and created something called a maintenance task. So a maintenance task is a type of background operation that all Windows Store applications can do. It doesn't require any kind of user consent, but it only runs when the user's got AC power connected. There are other types of background tasks that require user consent and can run more often, but it was very simple to do it this way. It's very easy. All I do is I build a Windows Runtime C# component. I implement a type called iBackgroundTask. I have to associate it with my application, so I have to add a reference to it. So you'll see that my cloudconnoisseur.maintenance type is associated with my main app. And I also have to configure it in my manifest. So if I go to package.manifest, and we look under declarations, you'll see that I have a background task. It's a system event, and the entry point is cloudconnoisseur.maintenance.logUploaderTask. So I'm going to run this app again. We've already crashed once. We've already got a crash dump. We want to see how we get that uploaded. We have this great infrastructure in Visual. There's one last thing I got to do. My mistake. We also have to register that event in code. Again, I've got a simple function to do that all ready to go. If I can just find the right place to put it. Register maintenance task. This code is pretty simple. All I'm going to do is I'm going to look to see whether the task is already registered. Background task registration is persistent across app runs. So you don't need to keep registering it every single time you run your app. But you pretty much need to check every time to make sure that it is active, because you could always be the first time. And it's very simple. I register the name of the task. These are just, I put these in const strings up here to make it so I wouldn't have to type them. I set a trigger, which is every 15 minutes, and then I register. This is very simple code. The code for doing this is up on in the MSDN. It's very simple. So now I'm going to run this. Did I recompile? Let's see. And I can actually trigger my uploader task. I can do that directly from Visual Studio. So I'm not going to wait the 15 minutes. I'm going to register this event. And so now it's running. So I come in. I have to get a deferral. Because this is an asynchronous operation, we need to, a deferral is a common pattern you see across Windows Store applications when we want to run some type of asynchronous operation. We get a deferral, and then we'll close that deferral when we're done. And this is very simple. We're going to go look in that same folder where the logs are uploaded. We're going to get a list of them. Because it's a background task, this takes a little bit longer than you would expect. And then we're going to upload it. So I'm going to create a background uploader. I'm going to use the put method. This is important because we want the background uploader to automatically retry if it fails. If you use post, which is the default, because of the semantics of the web, post is not considered idempotent. Put is. So you set it to put. If it fails, if your application, if the user shuts it down and has to restart, that will still get scheduled and will still get uploaded at some point in the future. I create an upload. I've got my URI already in this const string, and I call start upload. And if we wait a second, now we've broken. Now we're on the web side. So I'm now going to persist this off to disk. This is all very simple, boring code. We're not going to do too much. And as we walk through, now we're back over in the client app. I can get the upload information. I can see that it was a response code of 201, in which case I can say, great, I can now delete that log file. I don't need to keep it around on the disk. Now we can go off and we can look in the folder where we put it, and we can see here's that ETL file with the random GUID that I generated. I'm going to run for the purposes of time, I'm going to run this simple, this utility that comes with the SDK, and it will generate an XML version of that. And we can see here, let me just up the font here a little bit. So I remember to do the font in Visual Studio. And this is an XML dump of what's in the ETL file. ETL, event tracing log, those are the standard way we represent these things. Of course, you could do some other type of processing using the command line on stage in a demo is probably not the way you would do it in production. But if we scroll down, we can see these various events. Here's the onLaunched event for the Cloud Connoisseur app channel. There's certain sets of information that are always logged, right? So there's what level, what are the keywords, what was the time. We keep scrolling down. Here's the image pointer pressed event. And if we keep going down, we'll get here's the unhandled error event. And if we go down further, here's the error message, something bad happened. And that's the end of the log. So now, of course, in this case, it's not very useful because it's a pretty simple app. But if I've been doing this kind of logging, now I actually have a record of all the things that happened in my app that preceded the point where I crashed. And I have a much better chance of being able to troubleshoot it. So let's go back to the slides to sum up. So, what was the message at the beginning? You need to monitor and regularly improve the quality of your app in order to avoid that #1 cause for bad reviews, unreliability. You want to regularly review how your app is doing out there in the ecosystem on the Windows Dev Center. We provide you some good telemetry that gives you a great high-level view of how you're doing. But you need to supplement that with additional logging so that you have a better sense so that you know what's going on. You know whether that string is a social security number or a band name. You're subject to those same rules. So be sure that you're cognizant of the user's privacy. But if you know that a certain string doesn't have private information, then you can log it and you can take care of it. And it will help you understand better what's happening in your app in the field. And you can take advantage of these great new logging and error APIs that are new in Windows 8.1, logging channel, logging session, file logging session, an unhandled error detected event, in order to be able to get a really good sense of what's happening in your application. A couple of other related sessions. Some of these have actually already occurred, but you'll always be able to catch them on demand on Channel 9. There's a sort of a partner talk to this one, which talks more about desktop app crash information collection, improved application health by leveraging crash analytics collected from end users. There was a talk yesterday from Patterns and Practices about how to go about testing your app. As I said at the beginning, testing is not sufficient. It's critical, but it's not sufficient. Francis Chung's talk on things to test is a great talk to review about some of the things that those guys figured out as they were building a line of business style application for the Windows Store. And tomorrow, my dev manager, Martin Lovell, is going to do a talk on the internals of the Windows Runtime Threading model. Also relevant because obviously we talk a lot about how errors propagate across threads and that type of thing. With that, I would like to make sure everybody gets a chance. Please eval this session. Let us know how we did. Let us know how we're doing so we can do a better job for you next year, and every other year we do build. And with that, I'm available for questions, and we got about 2 minutes, or about 3 minutes, so I'll do some questions here in front of the mic, and then I'll also be down in the big room afterward if you want to come by and ask further questions.